Okay, in this video, I want to talk about another way that we can sort of classify differential equations. This time, based on whether it's what's called an autonomous equation or a non-autonomous equation. And we're going to talk about that in detail and define the notion of being an autonomous equation. So it's real simple. An autonomous equation is one which just depends on where the equation doesn't involve the independent variable at all. Now, sometimes I find students are confused by the notion of a dependent variable versus an independent one. We very often use the letter x to denote an independent variable. This is something that, given some value of x, you are given that value of x. It doesn't depend on anything else. Whereas you might have some function, you might have some other variable, which you might call y, which is in fact a function of x implicitly, right? So y of x. So in this case, we say that y is the dependent variable. And it depends on the independent variable x. Now, x and y are not always going to be the names or the letters that we use for our independent and dependent variables. You could also have something like displacement, s, which we've talked about in the past. This could depend on maybe a variable t, in which case, in this kind of situation here, s is the dependent variable. While t is the independent variable in this setup. Okay, so that's the distinction between being an independent variable and a dependent one. And we can make the following definition then for differential equations. And I'll give examples after giving the definition. A differential equation is said to be autonomous. So I'm defining the notion of autonomous. If the equation does not depend on the independent variable. Alrighty. So some examples. Y prime equals kx, what ky rather. This is, I hope you recognize at this point, this is the exponential growth equation. And this is an autonomous equation. It's an autonomous first order linear differential equation, okay? Yeah, it's autonomous. And the reason is that it's autonomous is that there's no x's involved in this differential equation here. If I was to make an adjustment to this equation, if I was to write y prime equals k times xy, now all of a sudden this is a non-autonomous equation, because the independent variable x is making its existence known explicitly in the equation, right? So that makes it non-autonomous. In each case, each of these are first order linear differential equations, ordinary differential equations, but one is autonomous and one is non-autonomous, okay? One perspective that you can take is that is the following. So maybe I'll say it like this. Every first order equation can be written in the following way. If we assume y is the name of the dependent variable and x is the name of the independent variable, every first order ODE could be written as y prime equals f of xy. So what am I trying to communicate here? So here's y prime, That's the derivative of y. And this is some perhaps complicated expression involving x and y, okay? All mixed up. And every first order ODE can be written in this way for some choice of f of x, y. Okay? Now, an autonomous equation is one which can be written y prime equals f of y only. Okay? In other words, no x's involved there. You see what I'm saying? You see, this is a consequence of first order equations like this. Sorry, I should say, can I correct myself a little bit? This isn't just every autonomous equation can be written like this. This is specifically for first order autonomous equations. So let me actually erase that as well. Replace this with a first order. Oh no, what have I done? Oh well, you're just gonna have to deal with that. First order autonomous equation is one which can be written as the derivative of y is equal to some function of y only. So that's another perspective on the notion of being an autonomous equation. All right. We won't use this language when it comes to partial differential equations. This is really more of a way of classifying ordinary differential equations. But it's good to have this kind of these words to be able to talk about equations in a quick and easy way. That's enough for this video.